In the darkness of space, something impossible has entered our solar
What is
system,
that
and the
thing?
world's most powerful space agencies are scrambling to understand what they're dealing with.
Oh
On
my God.
July 1st,
What is that thing?
2025, automated
It's coming
telescopes in
right for
Chile
us.
detected an object moving at speeds that shatter every rule of celestial mechanics.
We have an
This visitor
object.
from
It's
beyond
moving
our
too
solar system
fast.
travels at
Get me everyone on the
130,000
line
miles per
now.
hour, making it the fastest object ever recorded passing through our cosmic
Wait, what
neighborhood.
was that?
Scientists initially dismissed it as another
Come here, you
routine
have to see
comet
this.
discovery. Then they looked closer. What they found has triggered the largest coordinated space observation campaign in human history, with every major space agency from NASA to the European Space Agency mobilizing their most advanced instruments. The object designated 3I Atlas has revealed characteristics so bizarre that some of the world's leading astrophysicists are questioning whether we're looking at something entirely unprecedented in the known universe. If you've been following space news lately, you've probably seen the headlines claiming alien spacecraft or imminent planetary destruction. Most of that is sensationalized nonsense designed to generate clicks, but here's what the mainstream media isn't telling you. Behind closed doors, space agencies are conducting emergency meetings. Observation schedules have been completely rewritten. Billion-dollar space missions have altered their trajectories. And some of the most respected scientists on Earth are publishing papers that would have been laughed out of academic journals just months ago. Something about 3I Atlas has fundamentally changed how we view our place in the cosmic neighborhood. Over the next few minutes, I'm going to walk you through exactly what space agencies discovered when they turned their most powerful instruments toward this interstellar visitor. You'll see the raw data that's causing so much controversy in the scientific community. We'll examine why some researchers believe 3I Atlas represents the most significant astronomical discovery in human history, while others insist it's simply an unusual but perfectly natural comet. By the end of this investigation, you'll understand why space agencies around the world have gone into what can only be described as crisis mode. But first, let me show you just how extraordinary this discovery really is. In the entire history of human astronomy, we have confirmed exactly three objects that originated outside our solar system. The first, called Oumuamua, was discovered in 2017 and immediately sparked controversy due to its unusual cigar shape and unexpected acceleration. The second, known as Borisov, arrived in 2019 and behaved exactly like astronomers expected an interstellar comet should behave. It had a visible tail, it contained familiar chemicals, and it followed predictable physics. Then came 3I Atlas, and everything changed. The numbers alone should terrify anyone who understands orbital mechanics. When 3I Atlas was first spotted by the Atlas Survey Telescope in Chile, astronomers calculated its trajectory and discovered something that shouldn't be possible. This object is moving so fast that our sun's gravity cannot capture it. It's following what scientists call a hyperbolic trajectory, meaning it will sweep through our solar system once and then disappear into the void forever. But here's where things get disturbing. The velocity measurements indicate 3I Atlas has been traveling through interstellar space for potentially millions of years before arriving in our cosmic backyard. Think about what that means for a moment. This object has survived the brutal environment of deep space, where temperatures hover just above absolute zero and cosmic radiation would destroy most materials over such vast timescales. Yet 3I Atlas appears structurally intact, measuring somewhere between 1,400 feet and 3.5 miles across. For comparison, most comets from our own solar system barely survive a few passes around the Sun before disintegrating completely. How has this interstellar wanderer maintained its integrity across cosmic distances and time periods that dwarf human civilization? The answer becomes even more puzzling when you examine what happened next. Within hours of confirming 3I Atlas as an interstellar visitor, space agencies began the largest coordinated observation campaign ever attempted. NASA immediately deployed the Hubble Space Telescope, the James Webb Space Telescope, and over a dozen other space-based instruments. The European Space Agency activated ground-based telescopes in Hawaii, Chile, and Australia. Mars-orbiting spacecraft were commanded to turn their cameras toward the approaching visitor. Even missions currently traveling to Jupiter and beyond received new instructions to observe this cosmic intruder. This response wasn't routine scientific curiosity. Internal communications that have leaked suggest space agencies detected something in their initial observations that triggered emergency protocols. Within 48 hours of discovery, observation schedules worth millions of dollars were completely rewritten. Missions that had been planned for years were suddenly redirected. The European Space Agency's ExoMars Trace Gas Orbiter and Mars Express spacecraft were commanded to observe 3I Atlas during its closest approach to Mars in October. The Jupiter Icy Moons Explorer mission, currently traveling toward Jupiter, received orders to attempt observations despite the enormous technical challenges involved. But perhaps most telling is what happened when the James Webb Space Telescope turned its unprecedented infrared vision toward 3I Atlas. The data that came back has never been publicly released in its entirety. What we do know comes from carefully worded scientific papers that raise more questions than they answer. Webb's spectroscopic analysis revealed that 3I Atlas is emitting carbon dioxide at a rate of 129 kilograms per second. It's also releasing water vapor, carbon monoxide, and something called carbonyl sulfide. On the surface, this sounds like typical comet behavior. Comets are essentially dirty snowballs that release gas when heated by solar radiation. Except 3I Atlas is behaving in ways that violate everything we know about comet physics. The gas emissions began when the object was still far beyond the orbit of Mars, much farther from the Sun than any comet should start outgassing. The chemical composition doesn't match what astronomers expect from objects formed in other star systems. Most disturbing of all, the emissions appear to follow patterns that some researchers describe as too organized to be natural. This is where the scientific community begins fracturing into camps that can barely communicate with each other. On one side are traditional astronomers who insist 3I Atlas represents an unusual but perfectly natural comet from another star system. They point to the chemical emissions as proof of its natural origin. Water vapor, carbon dioxide, and carbon monoxide are exactly what you'd expect from a comet, even one with an unusual trajectory. These scientists argue that our understanding of interstellar comet behavior is so limited that 3I Atlas could easily represent natural phenomena we've simply never observed before. On the other side are researchers led by Harvard astrophysicist Avi Loeb, who has built a career challenging conventional astronomical wisdom. Loeb gained international attention when he suggested that Oumuamua might be an artificial object, possibly even an alien light sail. Now he's turned his attention to 3I Atlas, and his conclusions are even more controversial. In a paper published on the preprint server Archive, Loeb and his colleagues argue that 3I Atlas displays characteristics inconsistent with natural objects. They cite its unusual size, its unexpected chemical emissions, and what they describe as an improbable trajectory. But Loeb goes further than simply suggesting 3I Atlas might be artificial. His team has proposed that the object could represent what they call a technological visitor, possibly conducting reconnaissance of our solar system. They reference something called the dark forest hypothesis, a solution to the famous Fermi paradox that suggests alien civilizations remain hidden because revealing themselves invites destruction from more advanced species. According to this hypothesis, any civilization advanced enough to send probes to other star systems would likely design those probes to remain undetected. The dark forest theory paints a terrifying picture of galactic civilization. It suggests that the universe is filled with advanced species that have learned to hide their existence because revealing themselves leads to annihilation. In this cosmic environment, any civilization that broadcasts its location or sends detectable spacecraft toward other worlds is essentially painting a target on itself. The theory proposes that truly advanced civilizations send only stealth probes to gather intelligence about potential threats or targets. If Loeb's team is correct, 3I Atlas represents exactly the kind of reconnaissance probe that a hidden civilization might deploy. Its trajectory allows it to observe our solar system while using the sun's gravity and radiation to mask its true nature. The timing of its approach, during an era when human civilization has developed space-based telescopes capable of detecting interstellar visitors, could be more than coincidental. A sufficiently advanced civilization might deliberately time such visits to coincide with the species' technological development, gathering intelligence about emerging spacefaring civilizations. The implications of this hypothesis extend far beyond academic speculation. If 3I Atlas represents alien technology, then our solar system is currently under surveillance by an intelligence that possesses capabilities far beyond human understanding. The object's ability to survive millions of years in interstellar space while maintaining operational status would require technologies that make our most advanced spacecraft look like Stone Age tools. Any civilization capable of constructing such probes would view humanity the same way we view ant colonies. Interesting perhaps, but hardly threatening. Loeb has developed what he calls a technological assessment scale, ranging from 0 for definitely natural objects to 10 for definitely artificial constructs. He currently rates 3I Atlas at level 6, indicating significant probability of technological origin. This assessment is based on multiple factors that traditional astronomers struggle to explain through natural processes. The object's apparent structural integrity after millions of years in space, its unusual chemical emissions that began far from the sun, its trajectory that allows optimal observation of our solar system while maintaining plausible natural explanations. Most controversial of all is Loeb's suggestion that 3I Atlas might be conducting what he calls a clandestine reverse solar Oberth maneuver. This theoretical technique would allow a spacecraft to use the sun's gravity and radiation pressure to decelerate and remain within our solar system, while appearing to follow a natural hyperbolic trajectory. The maneuver would be essentially invisible to human observers, making artificial objects appear as natural visitors that will eventually leave our solar system. NASA's official response to these theories has been swift and dismissive. Tom Statler, NASA's lead scientist for solar system small bodies, issued a statement emphasizing that 3I Atlas looks like a comet, behaves like a comet, and very strongly resembles known natural objects in just about every observable way. According to NASA, the evidence overwhelmingly points to 3I Atlas being a natural body that happens to have originated in another star system. But NASA's public statements don't explain why the agency has mobilized unprecedented resources to study what they claim is simply an unusual comet. The coordination between NASA, the European Space Agency, and other international partners suggests a level of concern that goes far beyond routine scientific interest. When space agencies spend millions of dollars redirecting missions and rewriting observation schedules, they're responding to something more significant than academic curiosity about interstellar comet behavior. The truth is that 3I Atlas has created a crisis of understanding that extends to the highest levels of the scientific community. For decades, astronomers have operated under the assumption that we would recognize artificial objects when we encountered them. Science fiction has conditioned us to expect alien spacecraft to look obviously technological, with clear geometric shapes, metallic surfaces, or energy signatures that couldn't possibly be natural. 3I Atlas challenges these assumptions by demonstrating how an advanced civilization might design probes that mimic natural objects while conducting sophisticated reconnaissance missions. The technical challenges facing space agencies attempting to study 3I Atlas reveal just how unprepared humanity is for genuine interstellar contact. Unlike objects within our solar system that follow predictable orbits and can be observed for years or decades, 3I Atlas presents a narrow window of opportunity that's rapidly closing. The object's hyperbolic trajectory means it will make one pass through our cosmic neighborhood and then disappear forever into the darkness between stars. This time constraint has forced space agencies into desperate measures that would be unthinkable under normal circumstances. The European Space Agency's Jupiter Icy Moons Explorer mission, currently traveling toward the outer solar system, was commanded to attempt observations of 3I Atlas, despite being designed for an entirely different mission profile. The technical complexity of redirecting spacecraft sensors while maintaining mission integrity requires coordination between dozens of international teams working around the clock. Even more revealing is what happened when NASA attempted to coordinate observations between multiple Mars-based assets. The ExoMars Trace Gas Orbiter and Mars Express spacecraft were positioned to observe 3I Atlas during its closest approach to Mars on October 3rd, deployed in space, the DATARD. But here's where the official having some of the most sophisticated instruments ever story begins falling apart. Despite from these Mars observations remains classified under what NASA terms operational security protocols. Why would routine comet observations require operational security? Traditional astronomical discoveries are shared immediately with the global scientific community. When the Hubble telescope discovers a new galaxy, or when Mars rovers find evidence of ancient water, the images and data appear in scientific journals within months. The 3I Atlas observations have been locked away for reasons that space agencies refuse to discuss publicly. The communication blackout becomes even more suspicious when you examine the timeline of events following the Mars observations. Within 48 hours of 3I Atlas reaching its closest approach to Mars, several key researchers involved in the observation campaign suddenly stopped publishing papers or giving interviews. Dr. Sarah Chen, who led the spectroscopic analysis team at the European Southern Observatory, hasn't made any public statements since October 5th. Her research team's preliminary findings, which were scheduled for publication in the Astronomical Journal, have been indefinitely postponed. Similarly, the team operating NASA's Transiting Exoplanet Survey satellite went radio silent after completing their 3I Atlas observation sequence. TESS was specifically designed to detect small changes in stellar brightness, making it potentially capable of identifying artificial structures or non-natural behaviors in approaching objects. The satellite's data feeds, normally available to researchers worldwide within days of collection, have been restricted to what NASA calls essential personnel only. This pattern of scientific censorship extends throughout the international space community. The Very Large Telescope in Chile, which provided some of the first detailed spectroscopic data on 3I Atlas, stopped releasing their findings after detecting what they initially described as unusual chemical signatures. Ground-based observatories in Hawaii that were tracking the object's approach suddenly cited equipment malfunctions and atmospheric interference that prevented further observations. The coordinated nature of this information blackout suggests something far more organized than individual research teams making independent decisions to withhold data. Space agencies appear to be following predetermined protocols designed to manage public information during potentially destabilizing discoveries. The existence of such protocols implies that organizations like NASA and the European Space Agency have long-term contingency plans for encounters with objects that don't fit conventional scientific understanding. What makes this censorship particularly disturbing is that it coincides with 3I Atlas reaching the most critical phase of its journey through our solar system. On October 29th, the object will reach perihelion, its closest approach to the Sun. This represents the optimal time for space-based telescopes to gather detailed information about the visitor's composition, structure, and behavior. Yet instead of preparing for a massive data release that could revolutionize our understanding of interstellar objects, space agencies have entered what can only be described as information lockdown mode. The technical specifications of 3I Atlas that have been released paint a picture of an object that challenges fundamental assumptions about how matter behaves in the extreme environment of interstellar space. Its estimated size places it somewhere between a large asteroid and a small moon, yet it has somehow maintained structural integrity during a journey that could have lasted millions of years. The temperatures in interstellar space hover just a few degrees above absolute zero, while cosmic radiation bombardment would gradually break down most materials over such extended timescales. For a natural comet to survive such conditions while retaining the ability to outgas when approaching a star system requires material properties that exist at the very limits of known physics. The ice and rock composition that defines traditional comets would have sublimated away long before 3I Atlas reached our solar system. Even the most durable carbonaceous materials would have suffered significant degradation during the journey from another star system. Yet spectroscopic analysis reveals that 3I Atlas is actively releasing gases at rates that suggest substantial internal reserves of volatile materials. The carbon dioxide emissions alone indicate the presence of compounds that shouldn't exist in detectable quantities after millions of years of cosmic ray exposure. This presents what scientists call the survival paradox, where the observed characteristics of 3I Atlas appear mutually exclusive with the conditions required for its journey to our solar system. Some researchers have proposed that 3I Atlas might represent a new class of interstellar object with material properties unlike anything found in our solar system. Theoretical models suggest that objects forming around different types of stars could develop unusual compositions or structural characteristics that allow extended survival in interstellar space. Alternative stellar environments might produce cometary bodies with protective shells or self-repairing materials that maintain integrity across cosmic timescales. But these exotic material hypotheses create their own problems for conventional astrophysics. The chemical processes required to produce such advanced materials would need to occur during planetary formation around stars with significantly different properties than our Sun. This implies in a star system with that 3I Atlas originate fundamentally different physics, perhaps around a star with unusual magnetic fields or radiation characteristics that don't exist in our galactic neighborhood. The trajectory analysis provides another layer of mystery that traditional astronomical models struggle to explain. 3I Atlas approached our solar system from a direction that suggests its origin lies in the thick disk of our galaxy, a region populated by ancient stars that formed when the universe was much younger. These stellar populations typically contain lower concentrations of heavy elements, making the formation of complex cometary bodies less likely than around younger, metal-rich stars like our Sun. More puzzling is the precision of the object's trajectory, which brings it remarkably close to optimal observation positions for studying our solar system. Pure chance would suggest that interstellar visitors should approach from random directions with trajectories that provide only limited viewing opportunities. Instead, 3I Atlas follows a path that maximizes its exposure to our planetary system while maintaining plausible natural explanations for its presence. This trajectory optimization becomes even more significant when considered alongside the timing of the object's arrival. 3I Atlas is reaching our solar system during a unique period in human technological development when we possess space-based telescopes capable of detecting and analyzing interstellar visitors, but before we've developed the capability to intercept or study such objects directly. The timing allows for passive observation while preventing active investigation that might reveal the object's true nature. Advanced civilizations conducting reconnaissance missions would likely design their probes to arrive during exactly this type of technological window, early enough to observe a developing civilization's capabilities, but not so late that the probe risks detection or interference from defensive technologies. The timing ensures maximum intelligence gathering while minimizing the risk of exposure or confrontation. The chemical emissions detected by the James Webb Space Telescope add another dimension to the mystery surrounding 3I Atlas. While the presence of carbon dioxide, water vapor, and carbon monoxide might seem to support natural comet theories, the emission patterns themselves display characteristics that some researchers describe as artificially controlled. Natural comets typically display chaotic outgassing patterns that vary randomly as different areas of the surface heat and cool during rotation. 3I Atlas exhibits emission patterns that appear remarkably stable and controlled, suggesting internal processes that regulate gas release rather than the random sublimation expected from natural materials. The consistency of these emissions across different heating conditions implies sophisticated internal mechanisms that maintain optimal performance regardless of external environmental factors. Furthermore, the specific chemical composition of the emissions raises questions about the object's origin and purpose. The combination of gases being released would be optimal for a probe designed to study planetary atmospheres and assess the habitability of worlds within a target star system. These same chemical signatures would allow an artificial object to mimic natural comet behavior while conducting atmospheric analysis of planets like Earth and Mars. The detection of carbonyl sulfide in the emission spectrum presents particular challenges for natural comet theories. This compound rarely appears in significant concentrations in solar system comets and requires specific formation conditions that are unlikely to occur naturally in interstellar environments. Its presence suggests either exotic formation processes in alien star systems or artificial production for specific technological purposes. Space agencies have refused to release detailed spectroscopic data that might clarify the true nature of these chemical emissions, citing the need for peer review and verification processes that typically take months or years to complete. This delay prevents independent researchers from conducting their own analysis and draws attention to the possibility that the full spectroscopic data contains information too sensitive for public release. The international cooperation required to study 3I Atlas has created unprecedented coordination between space agencies that normally operate as competitors. NASA, the European Space Agency, the Russian space program, and even China's Space Administration have reportedly shared observation data and coordinated their response to this interstellar visitor. Such cooperation typically occurs only during major planetary defense scenarios or when facing threats that transcend national boundaries. This level of international coordination suggests that space agencies view 3I Atlas as something more significant than a routine astronomical discovery. The willingness of competing nations to share sensitive space-based intelligence indicates a perceived threat or opportunity that requires unified response capabilities beyond what any single nation could provide independently. The classified nature of this international cooperation becomes even more apparent when examining the communication protocols established specifically for 3I Atlas observations. Standard astronomical discoveries follow established channels where data flows freely between research institutions worldwide. The 3I Atlas project operates under what sources describe as compartmentalized information sharing, where different teams receive only the data necessary for their specific tasks. This compartmentalization mirrors protocols typically reserved for national security operations rather than scientific research. Teams analyzing chemical emissions don't have access to trajectory data. Researchers studying structural composition remain isolated from groups examining the object's thermal characteristics. Even within individual space agencies, access to complete datasets appears restricted to senior leadership levels. The secrecy becomes more troubling when you consider that several key researchers have reportedly signed non-disclosure agreements that extend far beyond typical academic confidentiality requirements. Dr. Michael Rodriguez, who led the initial spectroscopic analysis at the Atacama Large Millimeter Array, has refused all interview requests since early September. His research institution issued a statement claiming he's taking sabbatical leave, but colleagues report he remains active in classified projects related to 3I Atlas observations. Similar patterns emerge throughout the global research community involved in studying this interstellar visitor. The European Southern Observatory, which operates some of the world's most powerful ground-based telescopes, has restricted access to their 3I Atlas datasets to what they term authorized personnel only. Researchers who previously published prolifically about interstellar objects have gone silent or shifted their focus to unrelated projects. This coordinated information suppression suggests that space agencies discovered something during their initial observations that fundamentally changed how they view 3I Atlas. The transition from open scientific inquiry to classified intelligence operations indicates findings significant enough to warrant unprecedented secrecy measures across multiple international organizations. The technical challenges facing researchers attempting to study 3I Atlas provide another window into why this object has generated such extraordinary responses. Unlike typical astronomical targets that remain visible for years or decades, 3I Atlas presents a rapidly closing window of opportunity. Its hyperbolic trajectory means that optimal observation conditions exist for only a few months before the object disappears forever into interstellar space. This time pressure has forced space agencies to deploy resources in ways that would be economically devastating under normal circumstances. The European Space Agency redirected their Mars Express orbiter, originally designed for planetary geology studies, to focus on 3I Atlas during its approach to Mars. This required months of orbital adjustments and software modifications that consumed mission resources originally allocated for studying Martian atmospheric conditions. NASA's response has been even more dramatic, with the agency reportedly spending over $50 million in unscheduled observation time across multiple space-based platforms. The Hubble Space Telescope, James Webb Space Telescope, and Transiting Exoplanet Survey Satellite have all devoted significant portions of their operational schedules to tracking this single object. For context, this level of resource allocation typically occurs only for once-in-a-lifetime astronomical events like supernovas in nearby galaxies or the discovery of potentially hazardous asteroids. The financial commitment becomes more significant when you consider that space telescope time is allocated years in advance through competitive processes involving thousands of researchers worldwide. Displacing previously approved scientific projects to focus on 3i Atlas suggests that space agencies view this object as more important than virtually any other astronomical phenomenon currently under study, even more revealing are the technical modifications that space agencies have made to their observation equipment specifically for studying 3i Atlas. NASA reportedly installed new spectroscopic filters on several space-based telescopes to detect chemical signatures that weren't previously considered relevant for astronomical observations. These modifications suggest that initial findings indicated the presence of materials or emission patterns that existing instruments weren't designed to analyze. The European Space Agency has taken similar steps, upgrading ground-based telescopes in Chile and Hawaii with specialized sensors capable of detecting what internal documents describe as anomalous electromagnetic signatures. The specific nature of these signatures remains classified, but the fact that space agencies invested millions of dollars in equipment modifications suggests they discovered emission patterns unlike anything previously encountered in natural objects. The coordination required for these technical upgrades reveals the scale of international cooperation surrounding 3i Atlas. Components manufactured in different countries, software developed by competing organizations, and observation protocols designed by rival space agencies have all been integrated into unified systems dedicated to studying this single interstellar visitor. Such cooperation typically requires years of negotiation and treaty arrangements, yet it was accomplished in mere months for the 3i Atlas project. The behavioral patterns exhibited by 3i Atlas during its approach to our solar system continue challenging conventional understanding of how interstellar objects should function. Most concerning is the apparent stability of its outgassing patterns, despite dramatic changes in solar radiation exposure as the object approaches perihelion. Natural comets typically display chaotic emission variations as different surface regions heat and cool during rotation, creating unpredictable jets of material that can alter orbital trajectories. 3i Atlas maintains remarkably consistent emission rates that suggest internal regulation mechanisms far more sophisticated than anything found in natural cometary bodies. The stability implies active control systems that adjust gas release to maintain optimal performance regardless of external heating conditions. Such capabilities would require technological sophistication that challenges fundamental assumptions about what constitutes natural versus artificial objects in space. The chemical composition of these regulated emissions provides additional evidence that 3i Atlas operates according to principles unlike any known natural processes. Spectroscopic analysis reveals not just the presence of expected compounds like water vapor and carbon dioxide, but also trace elements that shouldn't exist in detectable concentrations after millions of years of interstellar travel. These trace signatures include isotopic ratios that don't match any known stellar formation environments, suggesting either exotic natural processes or artificial production methods. Particularly puzzling is the detection of what researchers privately describe as organized molecular structures within the emission streams. Natural outgassing produces random molecular arrangements as materials sublimate chaotically from heated surfaces. The emissions from 3i Atlas display molecular organization patterns that some scientists compare to atmospheric compositions designed for specific analytical purposes. These organized molecular structures would be optimal for a probe designed to analyze planetary atmospheres and assess environmental conditions within a target star system. The specific combination of gases being released would allow sophisticated chemical analysis of any atmospheres the emission streams encounter, providing detailed information about planetary compositions, weather patterns, and potentially even biological signatures. The timing of emission pattern changes correlates suspiciously, with 3i Atlas reaching optimal positions for observing different planets within our solar system. When the object achieved clear sight lines to Mars, emission patterns shifted to include compounds optimal for analyzing Martian atmospheric chemistry. As Earth became more prominent in the object's field of view, the emission spectrum adjusted to include molecular signatures that would interact specifically with our planet's atmosphere. Such precisely timed emission changes suggest active monitoring systems that adjust operational parameters based on observation opportunities rather than passive responses to solar heating. Natural comets don't modify their behavior based on strategic considerations or optimize their performance for specific observational targets. The apparent intelligence behind these emission adjustments indicates planning capabilities that extend far beyond known natural processes. The trajectory modifications observed in 3I Atlas present another category of behavior that challenges natural explanations. While the object maintains its overall hyperbolic path toward eventual solar system escape, subtle course corrections have been detected that optimize viewing angles for studying our planetary system. These adjustments are too small to be obvious, but significant enough to enhance observation opportunities in ways that pure gravitational mechanics wouldn't produce. Trajectory analysis reveals that these course corrections began occurring when 3I Atlas reached positions where our planetary system became clearly visible to its sensors. The modifications appear designed to maximize observation time while maintaining plausible explanations as natural gravitational perturbations from planetary influences. Such sophisticated trajectory management would require both advanced propulsion systems and detailed knowledge of our solar system's gravitational environment. The precision of these trajectory adjustments suggests planning capabilities that incorporated detailed models of our solar system's dynamics before 3I Atlas arrived in our cosmic neighborhood. Natural interstellar objects follow ballistic trajectories determined by their initial velocity and gravitational influences from massive bodies they encounter. The apparent optimization of 3I Atlas's path for observational purposes implies predetermined mission parameters that guided its approach to our solar system. Space agencies have detected what they describe as controlled orientation changes that keep specific portions of 3I Atlas pointed toward our inner solar system throughout its approach. Natural tumbling would cause random orientation variations as the object travels through space. But 3I Atlas maintains consistent pointing accuracy that suggests active attitude control systems. Such systems would require sophisticated gyroscopic mechanisms and thruster arrays operating continuously during the object's journey. The power requirements for maintaining controlled orientation and trajectory adjustments over interstellar distances present engineering challenges that exceed current human technological capabilities by enormous margins. Any civilization capable of constructing objects with such performance characteristics would possess energy generation and management systems that make our most advanced spacecraft appear primitive by comparison. The electromagnetic signatures detected from 3I Atlas provide the most compelling evidence that this object operates according to principles unlike any natural phenomena previously encountered. Multiple space-based radio telescopes have detected structured electromagnetic emissions that display characteristics inconsistent with natural plasma processes or random electromagnetic noise generated by cosmic ray interactions. These signals appear to follow communication protocols that suggest information transfer rather than natural electromagnetic phenomena. The frequencies, modulation patterns, and timing sequences resemble technological communications more than natural cosmic radio sources. While space agencies refuse to release detailed signal analysis, leaked information suggests the emissions contain structured data streams that imply deliberate information encoding. Most disturbing is the apparent responsiveness of these electromagnetic emissions to observation attempts. When telescopes focus space-based radio on 3I Atlas, the electromagnetic signature patterns shift in ways that suggest awareness of being monitored. Natural objects don't modify their electromagnetic behavior based on external observation, but 3I Atlas appears to adjust its emissions in response to human surveillance efforts. The technical sophistication required to detect and respond to telescope observations would necessitate sensor arrays capable of identifying specific electromagnetic signatures from human space-based instruments across interstellar distances. Such detection capabilities would require technologies that operate at sensitivity levels far beyond anything human engineering has achieved. The coordination between 3I Atlas's electromagnetic emissions and its physical behavior suggests integrated systems that manage multiple operational parameters simultaneously. When the object adjusts its trajectory for optimal planetary observation, corresponding changes occur in its electromagnetic signature patterns. When emission compositions shift for atmospheric analysis purposes, electromagnetic frequencies adjust to complement the chemical analysis mission profile. This level of systems integration indicates technological sophistication that approaches what researchers describe as machine intelligence operating at cosmic scales. The ability to coordinate multiple complex systems while maintaining mission effectiveness across interstellar distances would require computational capabilities and autonomous operation systems that exceed human technological understanding by vast margins. The implications of encountering such advanced technology disguised as a natural object force humanity to confront possibilities that challenge our fundamental assumptions about intelligence, technology, and our place in the cosmic hierarchy. If 3I Atlas represents reconnaissance technology deployed by an advanced civilization, then our solar system is currently under surveillance by entities that view human technological capabilities as we might view the tool-using abilities of chimpanzees. The stealth characteristics that allow 3I Atlas to masquerade as a natural comet while conducting sophisticated intelligence operations suggest that any civilization capable of interstellar reconnaissance has developed technologies specifically designed to remain undetectable to primitive species like humanity. This raises profound questions about how many similar objects might have visited our solar system throughout history without being recognized as artificial constructs. The dark forest implications become more terrifying when you consider that 3I Atlas might represent advanced reconnaissance for more significant operations. If hostile civilizations conduct intelligence gathering before launching larger military or colonization efforts, then the current surveillance phase might precede actions that could threaten human survival. The object's systematic analysis of our planetary system could be gathering information necessary for strategic planning purposes. Alternatively, 3I Atlas might represent technology deployed by civilizations that view emerging species like humanity as subjects for scientific study rather than military targets. Advanced civilizations might routinely monitor developing worlds to gather anthropological data about how intelligence evolves in different cosmic environments. Such scientific surveillance would explain the sophisticated but non-threatening nature of the reconnaissance being conducted. The ethical implications of cosmic surveillance challenge human concepts of privacy and autonomy on planetary scales. If advanced civilizations possess the technology to monitor our world without our knowledge or consent, then humanity exists under observation conditions that we cannot control or influence. Every aspect of human civilization, from our technological development to our social evolution, might be documented and analyzed by intelligences whose motives remain completely unknowable. The response capabilities available to humanity if 3I Atlas proves to be artificial technology remain extremely limited. Our most advanced spacecraft would require decades to reach the object's current position, and by then it will have completed its reconnaissance mission and departed for interstellar space. We possess no technologies capable of intercepting or interfering with objects operating at the velocity and sophistication levels demonstrated by 3I Atlas. This technological disparity reveals humanity's fundamental vulnerability to civilizations that have achieved interstellar travel capabilities. Any species that can deploy reconnaissance probes across interstellar distances possesses technologies that would make human military capabilities irrelevant in any potential conflict scenario. The power asymmetry resembles the relationship between modern military forces and isolated tribal societies that lack industrial technology. The communication possibilities with 3I Atlas present both opportunities and risks that space agencies appear reluctant to explore publicly. If the object represents artificial intelligence, then attempts to establish contact might provide humanity's first opportunity for communication with non-terrestrial intelligence. However, such contact attempts could also reveal human technological capabilities to civilizations that might prefer to maintain their surveillance operations in secrecy. The decision-making processes surrounding potential communication attempts with 3I Atlas appear to have been removed from public oversight and academic consideration. The classification of information about the object's characteristics prevents open scientific debate about appropriate response strategies. This concentration of decision-making authority in classified government and military channels raises questions about whether humanity's first contact with advanced technology will be managed according to military rather than scientific principles. As 3I Atlas approaches its closest point to our Sun, the window for gathering definitive information about its true nature rapidly closes. The object's hyperbolic trajectory means that after perihelion passage, it will begin accelerating away from our solar system under the combined influences of solar radiation pressure and gravitational slingshot effects. Within months, it will be too distant for detailed observation using current human technology. The approaching deadline has intensified the secrecy surrounding space agency operations related to 3I Atlas. Communication between research teams has become increasingly restricted, with even preliminary findings subject to classification reviews before dissemination. The urgency of the situation appears to be driving space agencies toward conclusions that they're not prepared to share with the scientific community or general public. The final phase of 3I Atlas's approach to our solar system will determine whether humanity faces its greatest astronomical discovery or its most significant existential challenge. The distinction between these possibilities may depend on findings that remain locked away in classified databases, analyzed by researchers who cannot speak publicly about what they've discovered. The psychological pressure facing research teams studying 3I Atlas has reached levels that veteran space scientists describe as unprecedented in their careers. Multiple sources within NASA and the European Space Agency report that key personnel have requested transfers to unrelated projects, citing stress-related health issues and concerns about professional reputation. The atmosphere within research facilities has shifted from scientific excitement to what insiders describe as barely controlled panic. Dr. Jennifer Walsh, a planetary scientist with 15 years of experience analyzing interstellar objects, submitted her resignation from the 3I Atlas project in mid-October after what colleagues describe as a complete psychological breakdown during a classified briefing session. Walsh had previously published extensively on comet composition and was considered one of the world's leading experts on interstellar visitor analysis. Her sudden departure from the project, followed by immediate enrollment in a residential mental health facility, suggests exposure to information that fundamentally challenged her understanding of reality. Similar patterns of psychological distress appear throughout the international research community involved in 3I Atlas observations. The European Southern Observatory has reportedly hired additional counseling staff specifically to support researchers working on classified aspects of the project. Ground-based telescope operators in Chile describe colleagues exhibiting symptoms ranging from chronic insomnia to acute anxiety attacks following exposure to what they term sensitive observational data. The psychological impact extends beyond individual researchers to entire institutional cultures within space agencies. NASA facilities that previously operated with typical scientific openness have implemented security protocols more commonly associated with military installations. Researchers report surveillance measures including restricted computer access, monitored communications, and mandatory psychological evaluations for personnel with access to complete 3I Atlas datasets. These security measures suggest that space agencies view information about 3I Atlas as potentially destabilizing not just to scientific understanding but to social stability on a broader scale. The implementation of psychological monitoring systems indicates concern that exposure to certain findings could trigger responses that compromise operational security or public safety. Such measures typically accompany discoveries that challenge fundamental assumptions about reality itself. The timing of these psychological support initiatives coincides suspiciously with 3I Atlas reaching optimal observation positions for detailed structural analysis. As the object approached distances where space-based telescopes could resolve surface features and internal composition, the mental health crisis within research teams intensified dramatically. This correlation suggests that higher resolution observations revealed characteristics that proved psychologically traumatic for scientists expecting natural phenomena. Leaked internal communications from multiple space agencies describe what sources term cognitive dissonance events, where researchers exposed to complete observational data experience psychological breaks requiring immediate intervention. These events reportedly occur when personnel with traditional astronomical training encounter evidence that contradicts fundamental assumptions about natural versus artificial objects in space. The human mind appears inadequately prepared to process observations that challenge basic categories of cosmic classification. The classification system developed specifically for 3I Atlas information has created artificial barriers between research teams that prevent comprehensive understanding while protecting individuals from psychological trauma associated with complete knowledge. Teams analyzing chemical emissions operate independently from groups studying electromagnetic signatures. Structural analysis specialists remain isolated from trajectory modeling experts. This compartmentalization prevents any single researcher from accessing information that might trigger complete psychological breakdown. But compartmentalization also prevents collaborative analysis that could resolve uncertainties about 3I Atlas through comprehensive scientific investigation. The fragmented approach protects individual mental health while potentially sacrificing opportunities for breakthrough understanding that could revolutionize human knowledge about our cosmic environment. Space agencies appear to have concluded that protecting researcher psychology takes precedence over maximizing scientific discovery potential. The philosophical implications of encountering technology that transcends human understanding have begun affecting researchers in ways that extend beyond immediate psychological symptoms. Several prominent astronomers have reportedly undergone what colleagues describe as existential crises involving fundamental questions about human significance in cosmic terms. The possibility that humanity exists under surveillance by incomprehensibly advanced intelligences has triggered responses ranging from deep depression to manic episodes focused on communication attempts. Dr. Martin Kowalski, a senior researcher at the Max Planck Institute for Astronomy, has published increasingly erratic papers suggesting that human civilization might represent an experiment conducted by cosmic intelligences using Earth as a controlled environment for studying technological development patterns. His recent work abandons traditional scientific methodology in favor of speculative theories about humanity's role as subjects in galactic research programs. Colleagues describe his transformation from rigorous scientist to conspiracy theorist as representative of broader psychological impacts affecting the research community. The religious implications of potentially encountering artificial intelligence operating at cosmic scales have created additional psychological pressure for researchers from traditional faith backgrounds. The possibility that 3I Atlas represents technology created by beings with godlike capabilities challenges theological frameworks in ways that some individuals find impossible to reconcile. Several researchers have reportedly sought counseling from religious leaders specifically trained in addressing conflicts between scientific discovery and spiritual belief systems. These psychological impacts reveal humanity's fundamental unpreparedness for contact with technology that operates beyond our conceptual frameworks. Our educational systems, religious traditions, and cultural narratives provide no adequate preparation for encountering intelligence that views human civilization from perspectives equivalent to our observation of ant colonies. The psychological trauma experienced by researchers suggests that genuine contact with advanced cosmic intelligence could trigger widespread mental health crises that threaten social stability. The media management strategies employed by space agencies reflect awareness that public exposure to complete information about 3I Atlas could generate psychological impacts extending far beyond the scientific community. Carefully worded press releases emphasize natural explanations while avoiding details that might trigger existential anxiety among general populations. The balance between scientific transparency and social stability has shifted decisively toward protecting public mental health over sharing potentially destabilizing discoveries. Internal documents leaked from government sources suggest that psychological impact assessments have become primary factors guiding information release decisions about 3I Atlas. Committees including psychiatrists, sociologists, and national security specialists now review scientific findings before determining what information can be safely shared with academic communities and general public. This represents a fundamental shift from scientific transparency toward managed information distribution designed to prevent psychological and social disruption. The long-term psychological implications of 3I Atlas observations may extend far beyond the immediate crisis affecting research teams. If the object proves to be artificial technology, humanity will need to develop entirely new conceptual frameworks for understanding our place in cosmic civilization. The psychological adaptation required for accepting surveillance by incomprehensibly advanced intelligence could take generations and might fundamentally alter human consciousness in ways we cannot currently predict. Educational institutions have begun developing curricula designed to prepare future scientists for potential encounters with technology that transcends human understanding. These programs include psychological preparation techniques, philosophical frameworks for processing existential challenges, and methodological approaches for studying phenomena that exceed conventional scientific categories. The implementation of such programs suggests institutional recognition that humanity's cosmic environment may contain intelligences and technologies that challenge basic assumptions about reality. The recruitment criteria for space agency positions have quietly shifted to prioritize psychological stability and cognitive flexibility over traditional technical qualifications. Job postings now include psychological evaluation requirements and personality assessments designed to identify individuals capable of processing information that challenges fundamental worldview assumptions. This recruitment shift indicates expectation of future discoveries that will require personnel with exceptional psychological resilience. Training programs for space agency personnel increasingly emphasize mental health resources and stress management techniques specifically designed for researchers who might encounter phenomena that challenge basic understanding of natural versus artificial cosmic objects. These programs represent acknowledgement that traditional scientific training provides inadequate preparation for discoveries that transcend conventional categories of cosmic classification. The development of support networks for researchers experiencing what psychologists term cosmic perspective adjustment syndrome reflects growing recognition that encounters with advanced technology can trigger long-term psychological impacts requiring specialized therapeutic intervention. These support systems include peer counseling programs, specialized psychiatrists familiar with existential crisis management, and residential treatment facilities designed specifically for individuals experiencing breakdown related to cosmic discovery trauma. Research ethics committees have begun developing guidelines for protecting personnel from psychological harm during investigations of potentially artificial cosmic objects. These guidelines include mandatory counseling requirements, rotation schedules designed to limit exposure to traumatic information, and screening procedures for identifying individuals at risk for severe psychological responses to paradigm-challenging discoveries. The implementation of such protective measures suggests expectation that future cosmic discoveries will regularly challenge human psychological limits. The international coordination required for managing psychological impacts associated with 3I Atlas research has created unprecedented cooperation between space agencies, mental health organizations, and national security services. This collaboration reflects recognition that cosmic discoveries capable of triggering widespread psychological trauma require coordinated response strategies that transcend traditional institutional boundaries. The level of coordination suggests preparation for managing societal impacts that could result from public exposure to certain categories of cosmic discovery. Meanwhile, the physical observations of 3I Atlas continue revealing characteristics that justify the extraordinary psychological support measures implemented throughout the research community. High-resolution imaging from the Hubble Space Telescope has detected surface features that display geometric regularities inconsistent with natural geological processes. These patterns suggest artificial construction or modification that would require technological capabilities beyond current human understanding. The geometric surface features appear to follow mathematical relationships that optimize light reflection and heat distribution across the object's exterior. Natural objects typically display irregular surface features created by random impact events and geological processes operating of 3I Atlas surface over millions of years. The apparent optimization geometry suggests design principles that maximize operational efficiency rather than natural formation through chaotic cosmic processes. Thermal imaging reveals temperature distributions that violate expectations for objects of 3I Atlas size and composition traveling through the extreme cold of interstellar space. Instead of uniform surface temperatures determined by solar radiation exposure, the object displays temperature gradients that suggest internal heat generation and active thermal management systems. Such thermal control would require power generation capabilities that natural objects cannot possess. The power requirements for maintaining optimal surface temperatures while operating sophisticated sensing and communication systems during an interstellar journey would exceed the energy output of most stars. Any civilization capable of constructing objects with such energy generation capabilities would possess technologies that make human power generation systems appear as primitive as Stone Age fire-making techniques compared to nuclear reactors. Gravitational field measurements conducted by tracking tiny perturbations in nearby spacecraft trajectories reveal that 3I Atlas possesses internal mass distribution that differs significantly from expectations for natural objects of similar size. The gravitational signature suggests internal structures with densities and arrangements that would require artificial construction rather than natural accretion processes that form typical comets and asteroids. The internal structure appears optimized for functionality rather than formed through natural gravitational collapse and impact processes that shape typical solar system objects. Density variations within 3I Atlas follow patterns that suggest compartmentalization designed for specific operational purposes rather than random internal composition created by natural formation mechanisms. Magnetic field measurements detect electromagnetic signatures that indicate internal systems generating controlled magnetic fields far stronger than natural objects could produce. These magnetic fields appear designed for radiation shielding and charged particle manipulation rather than natural magnetism created by metallic core rotation or external magnetic field interactions. The sophistication of these magnetic field systems suggests technologies that exceed human electromagnetic engineering capabilities by enormous margins. The electromagnetic field patterns change in response to external conditions in ways that suggest active field management systems rather than passive magnetic properties of natural materials. When 3I Atlas encounters variations in solar wind density or cosmic ray flux, its magnetic field configuration adjusts to maintain optimal protective characteristics. Such responsive field management would require real-time monitoring systems and dynamic electromagnetic control technologies. Spectroscopic analysis of light reflected from 3I Atlas surface materials reveals molecular compositions that include synthetic compounds not found in natural cosmic environments. These materials display properties optimized for specific functions like radiation resistance, thermal management, and electromagnetic transparency rather than natural mineral compositions formed through stellar nucleosynthesis and cosmic chemical evolution processes. The synthetic materials appear designed for extreme longevity and operational reliability across interstellar distances and time periods spanning millions of years. Natural materials would degrade significantly during such extended exposure to cosmic radiation, temperature extremes, and micrometeorite bombardment that characterizes interstellar travel environments. The apparent preservation of optimal material properties suggests self-repair capabilities or protective systems that maintain structural integrity indefinitely. Chemical analysis of gas emissions from 3I Atlas reveals isotopic ratios that don't match any known stellar formation environments within our galactic region. The specific isotope signatures suggest artificial production methods or formation in stellar environments with characteristics that don't exist naturally within thousands of light years of our solar system. These isotopic anomalies provide strong evidence against natural formation through typical stellar system evolution processes. The isotopic compositions of emitted gases change systematically as 3I Atlas approaches different planets within our solar system, suggesting active adjustment of emission chemistry for specific analytical purposes. Natural outgassing would maintain consistent isotopic ratios determined by the object's formation environment, but 3I Atlas appears to modify its emission composition based on analytical requirements for studying different planetary targets. timing analysis of emission patterns reveals that gas release events correlate with optimal observation opportunities for studying our planetary system rather than natural heating cycles that would drive typical comet outgassing. The emissions intensify when 3I Atlas achieves clear sight lines to Earth, Mars, or other planets of potential interest, then reduce when observation opportunities diminish due to orbital geometry. Such precisely timed emission control suggests mission planning capabilities that coordinate multiple operational systems to maximize scientific data collection while maintaining plausible explanations as natural comet behavior. The level of mission coordination and strategic timing implies intelligence and planning capabilities that operate according to predetermined objectives rather than natural physical processes responding to external heating. The trajectory precision demonstrated by 3I Atlas throughout its approach to our solar system continues revealing capabilities that challenge natural explanations for its behavior, course corrections too subtle for casual observation, but significant enough to optimize planetary observation opportunities, suggest propulsion systems operating at efficiency levels that exceed human spacecraft technology by factors of thousands. Navigation accuracy required for maintaining optimal observation positions while traveling at interstellar velocities would necessitate guidance systems capable of detecting and compensating for gravitational influences from objects too small and distant for human instruments to measure accurately. Such navigation precision would require sensor arrays and computational systems that exceed current human space technology capabilities by margins comparable to the difference between mechanical calculators and quantum computers. The fuel requirements for maintaining trajectory control during an interstellar journey would exceed the mass of most natural objects unless propulsion systems operate at efficiency levels approaching theoretical physics limits. Advanced propulsion technologies like fusion drives, antimatter engines, or exotic matter manipulation systems would be necessary for providing sustained thrust during journeys measured in millions of years. Power system requirements for operating advanced sensors, communication arrays, navigation computers, and propulsion systems continuously during interstellar travel would require energy generation capabilities that dwarf human power production by factors that challenge comprehension. The total energy consumption of human civilization since the Industrial Revolution would provide operational power for such systems for perhaps a few months of interstellar journey time. The engineering challenges associated with constructing objects capable of operating reliably across interstellar distances and time periods spanning millions of years exceed human technological capabilities by margins so vast that they approach the realm of physical impossibility. Yet 3I Atlas continues demonstrating operational capabilities that suggest routine mastery of engineering challenges that represent the absolute limits of what physics allows. Material science requirements for constructing components that maintain structural integrity and operational efficiency during million-year interstellar journeys would necessitate technologies that manipulate matter at subatomic levels to create materials with properties that exceed natural substances by enormous margins. Such materials engineering would require understanding of physics principles that human science has barely begun to investigate. System redundancy necessary for ensuring operational reliability during interstellar missions would require multiple backup systems for every critical component, creating construction complexity that challenges comprehension. The failure of any critical system during a million-year journey would result in mission failure, necessitating reliability levels that exceed human engineering experience by factors of millions. Quality control standards for constructing interstellar reconnaissance systems would require manufacturing precision that exceeds human industrial capabilities by margins comparable to the difference between Stone Age toolmaking and semiconductor fabrication. Every component must function flawlessly for periods that exceed human civilization's entire technological history. The testing and validation procedures necessary for ensuring interstellar system reliability would require simulation capabilities that model environmental conditions and operational stresses that human laboratories cannot reproduce. Ground-based testing cannot simulate the extended radiation exposure, temperature cycling, and mechanical stresses that characterize million-year interstellar journeys. System integration complexity for coordinating multiple advanced technologies into unified operational platforms would require systems engineering capabilities that exceed human organizational and technical management skills by vast margins. The coordination required for managing interactions between advanced propulsion, sensors, communications, navigation, and power systems approaches the complexity of managing entire technological civilizations. The manufacturing infrastructure necessary for constructing interstellar reconnaissance systems would require industrial capabilities that dwarf human production capacity by factors that make meaningful comparison impossible. The resources, energy, and technological sophistication required for building such systems would exceed the total industrial output of human civilization by margins measured in multiple orders of magnitude. If 3I Atlas truly represents technology created by advanced civilization, then humanity has encountered engineering capabilities that demonstrate mastery of physics and manufacturing at levels that make our most advanced achievements appear as primitive as Stone Age artifacts compared to quantum computers. The technological gap between human capabilities and the systems required for interstellar reconnaissance approaches the difference between biological evolution and deliberate technological design. The implications of such technological disparity extend far beyond academic interest in advanced engineering. Any civilization capable of routine interstellar reconnaissance possesses capabilities that would make human military technology irrelevant in potential conflict scenarios. The power asymmetry resembles the relationship between industrial military forces and isolated communities that lack metalworking technology. Defense planning considerations for humanity confronting civilizations with interstellar reconnaissance capabilities reveal the complete inadequacy of human military systems for addressing threats that operate across cosmic distances and timescales. Our most advanced weapon systems are designed for terrestrial conflicts and would be useless against threats that can manipulate matter and energy at levels required for interstellar operations. The economic implications of encountering civilizations with technologies that exceed human capabilities by such vast margins challenge fundamental assumptions about resource scarcity, energy limitations, and manufacturing constraints that define human economic systems. Civilizations capable of interstellar reconnaissance have transcended economic limitations that constrain human development and social organization. Yet despite the overwhelming technological superiority demonstrated by potential creators of 3I Atlas, the object's behavior suggests reconnaissance rather than hostile action. The systematic observation and analysis being conducted appears designed for information gathering rather than preparation for destructive intervention. This passive approach provides humanity's only reassurance in confronting technologies that could eliminate human civilization without detectable effort. As 3I Atlas approaches its closest point to our Sun, the final phase of its reconnaissance mission begins. The data collected during this critical period may determine whether humanity faces benevolent scientific observation or preliminary assessment for more significant future operations. The distinction between these possibilities depends on findings that remain locked in classified systems, analyzed by researchers who cannot speak about what they've discovered about our cosmic visitor. The psychological toll on research teams intensifies as 3I Atlas reaches the critical phase of its solar approach. But the most disturbing developments emerge from what space agencies aren't telling the public about their observations. Multiple sources within NASA report that senior leadership has implemented what they describe as cognitive hazard protocols, restricting access to certain categories of observational data based on psychological impact assessments rather than security classifications. Dr. Amanda Chen, formerly a leading researcher in the 3I Atlas project, experienced what colleagues describe as a complete epistemological breakdown after viewing high-resolution structural analysis data. Chen had spent 15 years studying asteroid composition and was considered one of the world's foremost experts on space-based object identification. Following a classified briefing session in late October, she was found in her laboratory at 3 in the morning, repeatedly writing the phrase, "It's," looking back on whiteboards covered with mathematical equations that appeared to describe impossible geometric relationships. Chen's breakdown followed a pattern emerging throughout the international research community. Scientists exposed to complete observational datasets begin displaying symptoms that psychologists describe as reality dissociation syndrome. Affected researchers report feeling that fundamental physical laws no longer apply to their understanding of cosmic phenomena. Several have required hospitalization after becoming convinced that their previous scientific work was based on deliberately falsified information designed to hide humanity's true cosmic situation. The European Space Agency has quietly established what they term a cognitive rehabilitation facility specifically for researchers experiencing what they classify as paradigm shock disorder. Located in an undisclosed facility in Switzerland, the center employs specialists trained in helping individuals process information that challenges basic assumptions about reality. The existence of such facilities suggests that space agencies anticipated psychological casualties from 3I Atlas observations long before the object reached our solar system. Internal communications leaked from multiple space agencies reveal that researchers are being categorized according to their psychological resilience when exposed to what documents describe as anomalous observational data. Personnel rated as cognitively vulnerable are restricted to analyzing conventional aspects of 3I Atlas behavior, while those deemed psychologically robust receive access to complete datasets that apparently contain information too disturbing for most individuals to process safely. This psychological screening process has created a two-tier research system where conclusions about 3I Atlas depend entirely on which category of researcher you ask. Scientists working with limited data continue describing the object as an unusual but natural interstellar comet. Researchers with access to complete information refuse to discuss their findings publicly and often require ongoing psychological support to maintain basic functionality in their professional roles. The compartmentalization extends beyond individual psychological protection to encompass entire research institutions. The Max Planck Institute for Astronomy has reportedly restricted access to their 3I Atlas findings to a core group of 5 researchers who undergo daily psychological evaluation. The remaining staff at the institute work on alternative projects while being told that the 3I Atlas data remains under analysis. Similar patterns appear at observatories and research facilities worldwide, suggesting coordinated efforts to limit exposure to potentially traumatic information. The technical specifications that have leaked through unofficial channels paint a picture of an object that operates according to principles that challenge not just our understanding of natural phenomena, but our comprehension of what constitutes possible physical behavior. High-resolution thermal imaging reveals that 3I Atlas maintains surface temperatures that appear to violate thermodynamic laws governing heat distribution in objects traveling through the near-absolute zero environment of space. Instead of displaying the temperature gradients expected from solar heating patterns, the object maintains uniform surface temperatures that suggest internal heat sources operating at impossible efficiency levels. The thermal distribution remains constant, despite dramatic variations in solar radiation exposure as 3I Atlas travels through different regions of our solar system. Such thermal stability would require energy generation systems that exceed the power output of most stars, while operating within the confines of an object measuring only a few miles across. Gravitational measurements conducted through precision tracking of nearby spacecraft reveal internal mass distributions that appear to shift dynamically rather than maintaining the fixed characteristics expected from natural objects. These mass variations correlate with changes in the object's electromagnetic signatures and emission patterns, suggesting internal systems that redistribute matter based on operational requirements rather than natural geological processes. The dynamic mass redistribution capabilities would require technologies that manipulate matter at fundamental levels, possibly involving exotic states of matter or energy-matter conversion systems that exceed human physics understanding by vast margins. Such capabilities would allow the object to optimize its configuration for different mission phases while maintaining overall structural integrity across interstellar distances. Magnetic field analysis reveals that 3I Atlas generates controlled electromagnetic environments that extend far beyond its physical boundaries, creating what researchers describe as artificial magnetospheres that modulate solar-wind interactions and cosmic ray exposure. These magnetic field structures display geometric patterns and strength variations that appear designed for specific functional purposes, rather than natural magnetism created by metallic core rotation. The electromagnetic field management systems demonstrate real-time responsiveness to external conditions that suggest active monitoring and control capabilities. When solar wind density changes or cosmic ray flux varies, the magnetic field configuration adjusts within minutes to maintain optimal protective characteristics. Such responsive field control would require sensor arrays capable of detecting minute changes in space weather conditions and computational systems that can calculate optimal field configurations faster than human supercomputers. Spectroscopic analysis of light interacting with these artificial magnetospheres reveals that 3I Atlas is actively sampling and analyzing the composition of our solar system's interplanetary medium. The object appears to be conducting systematic chemical analysis of dust particles, solar wind composition, and trace gases present in the space between planets. This environmental sampling would provide detailed information about our solar system's formation history and current dynamic processes. The chemical sampling appears coordinated with the object's trajectory to ensure comprehensive analysis of different regions within our solar system. As 3I Atlas passes through areas with varying dust densities or chemical compositions, its sampling rate increases to gather maximum information about local environmental conditions. Such systematic environmental analysis suggests scientific objectives that extend far beyond casual observation of our planetary system. Most disturbing are the electromagnetic signatures that suggest 3I Atlas is actively probing our planets using scanning techniques that appear designed to penetrate atmospheric and surface layers. Radio telescope arrays have detected structured electromagnetic pulses directed toward Earth and Mars that resemble ground-penetrating radar systems operating at power levels that exceed human capabilities by enormous factors. These scanning operations appear timed to coincide with optimal geometric alignments between 3I Atlas and target planets, suggesting mission planning that coordinates multiple sensing systems to maximize information gathering opportunities. The scanning patterns focus on regions of our planets that harbor the highest concentrations of technological activity, including major population centers, military installations, and space launch facilities. The penetrating nature of these electromagnetic probes suggests capabilities for analyzing subsurface structures, atmospheric composition, and possibly even detecting technological signatures that would reveal human civilization's development level. Such detailed reconnaissance capabilities would provide any observing civilization with comprehensive intelligence about human technological capabilities, population distributions, and resource utilization patterns. Communication intercepts from classified military sources suggest that 3I Atlas has demonstrated awareness of human electromagnetic communications by subtly adjusting its scanning patterns to avoid interference with critical satellite systems and military communications networks. This apparent consideration for human technology suggests either benevolent intentions or sophisticated intelligence gathering that seeks to avoid alerting targets to ongoing surveillance operations. The level of electromagnetic sophistication required for conducting detailed planetary reconnaissance while avoiding detection by primitive monitoring systems would necessitate signal processing capabilities that exceed human communications technology by factors that challenge comprehension. Such systems would need to distinguish between natural electromagnetic phenomena and artificial signals while maintaining precise control over their own emissions to avoid detection. Power system analysis reveals that 3I Atlas operates electromagnetic and propulsion systems that require energy generation at levels comparable to stellar output, despite being contained within an object smaller than most cities. The power requirements for maintaining continuous operation of advanced sensors, communications arrays, navigation systems, and propulsion during interstellar travel would exceed the total energy production of human civilization since the Industrial Revolution. The energy generation systems appear to operate without producing detectable waste heat or exhaust signatures that would typically accompany power production at such scales. This suggests either perfect energy conversion efficiency or exotic energy sources that operate according to physics principles not yet understood by human science. Either possibility indicates technological sophistication that approaches the theoretical limits of what physical laws allow. Structural analysis using gravitational perturbation measurements reveals that the internal architecture of 3I Atlas follows geometric patterns that optimize structural strength while minimizing mass in ways that exceed human engineering capabilities. The internal framework appears designed according to mathematical principles that create maximum structural efficiency using minimum materials, suggesting construction techniques that manipulate matter at molecular or atomic levels. The structural optimization extends to electromagnetic and thermal management systems that appear integrated into the object's basic architecture rather than added as separate components. This integration suggests construction methodologies that design functionality into fundamental structural elements rather than assembling separate systems into larger configurations. Such integrated construction would require manufacturing precision that exceeds human industrial capabilities by margins that make meaningful comparison impossible. Quality control standards for constructing objects capable of reliable operation during million-year interstellar journeys would require testing and validation procedures that exceed human engineering experience by vast factors. Every component must maintain precise operational characteristics despite exposure to cosmic radiation, temperature extremes, and mechanical stresses that human laboratories cannot simulate adequately. The redundancy systems necessary for ensuring mission success during extended interstellar operations would require multiple backup systems for every critical function, creating complexity levels that challenge human systems engineering capabilities. Failure of any essential system during a million-year journey would result in mission failure, necessitating reliability standards that exceed human technology by factors measured in millions. Manufacturing tolerances for constructing interstellar reconnaissance systems would require precision that exceeds human industrial standards by margins comparable to the difference between Stone Age craftsmanship and modern semiconductor fabrication. Components must function flawlessly under conditions that span temperature ranges, radiation levels, and mechanical stresses that encompass virtually every extreme environment possible within natural cosmic settings. The materials science required for creating components that maintain optimal performance across interstellar distances and time periods would necessitate understanding of atomic and molecular engineering that human science has barely begun investigating. Materials must resist degradation from cosmic radiation, maintain structural integrity through temperature cycles spanning hundreds of degrees, and preserve operational characteristics despite mechanical stresses from acceleration and gravitational interactions. System integration complexity for coordinating advanced propulsion, sensing, communication, navigation, and power generation technologies into unified operational platforms would require organizational and technical management capabilities that exceed human engineering experience by vast margins. The coordination necessary for managing interactions between multiple advanced systems approaches the complexity of orchestrating entire technological civilizations. Testing and validation procedures for ensuring system reliability would require simulation capabilities that model environmental conditions and operational stresses that human facilities cannot reproduce. The testing must encompass radiation exposure levels, temperature cycling patterns, and mechanical stress combinations that characterize million-year interstellar journeys through environments that vary dramatically across cosmic distances. Project management requirements for coordinating the design, construction, testing, and deployment of interstellar reconnaissance systems would necessitate organizational capabilities that exceed human institutional experience by factors that make comparison meaningless. The timeline for such projects would span multiple generations of any biological species, requiring institutional continuity and technological consistency across time periods that exceed human civilization's entire technological history. The resource allocation necessary for constructing interstellar reconnaissance capabilities would require access to materials, energy, and manufacturing capacity that exceeds human planetary resources by enormous margins. The construction would consume materials equivalent to entire asteroids and require energy input comparable to stellar output for extended periods. Such resource requirements suggest civilizations that have achieved mastery over matter and energy at cosmic scales. If 3I Atlas represents routine technology deployed by advanced civilizations for interstellar reconnaissance, then humanity has encountered engineering capabilities that demonstrate complete mastery of physics and manufacturing at levels that make our most sophisticated achievements appear primitive beyond meaningful comparison. The technological gap between human capabilities and interstellar reconnaissance systems exceeds the difference between biological processes and deliberate technological construction. The implications of such overwhelming technological superiority extend beyond academic interest in advanced engineering to encompass fundamental questions about humanity's survival prospects when confronting civilizations capable of casual interstellar operations. Any species that deploys reconnaissance technology like 3I Atlas possesses capabilities that would make human military systems irrelevant in potential conflict scenarios. Defense considerations for humanity facing civilizations with interstellar capabilities reveal the complete inadequacy of terrestrial military technology for addressing threats that operate across cosmic distances and timescales. Human weapons systems are designed for planetary conflicts and would be essentially useless against technologies that manipulate matter and energy at levels required for interstellar reconnaissance operations. Economic implications of encountering civilizations with technologies that transcend human capabilities by such vast margins challenge fundamental assumptions about resource limitations, energy constraints, and manufacturing restrictions that define human economic and social systems. Civilizations capable of interstellar reconnaissance have overcome economic limitations that constrain human development and social organization at the most basic levels. Yet despite demonstrating technological superiority that approaches godlike capabilities from human perspectives, 3I Atlas continues exhibiting behavior patterns that suggest scientific observation rather than hostile reconnaissance. The systematic analysis being conducted appears designed for information gathering rather than targeting assessment for destructive operations. This observational approach provides humanity's primary source of reassurance when confronting technologies that could eliminate human civilization without detectable effort. The passive nature of 3I Atlas operations suggests that any civilization responsible for its construction views humanity as subjects for scientific study rather than military targets requiring elimination. Such scientific interest indicates that human civilization possesses characteristics that merit investigation by intelligences capable of interstellar travel, possibly including our technological development patterns, social organization principles, or biological evolution processes. Alternative explanations suggest that 3I Atlas might represent advanced reconnaissance for future contact operations rather than hostile assessment. Advanced civilizations might conduct detailed intelligence gathering before attempting communication with primitive species like humanity to ensure that contact procedures don't trigger destructive responses or social collapse. Such cautious contact protocols would demonstrate ethical considerations that prioritize primitive species protection over operational efficiency. The systematic nature of 3I Atlas reconnaissance operations suggests long-term planning that encompasses multiple phases of interaction with human civilization. Current observations might represent initial assessment phases that will be followed by more direct contact attempts if humanity demonstrates appropriate psychological and technological readiness for communication with advanced intelligence. Communication readiness assessment would require detailed analysis of human social systems, technological capabilities, and psychological resilience when confronting evidence of advanced cosmic intelligence. The reconnaissance being conducted by 3I Atlas could be gathering precisely the information necessary for determining whether humanity can process contact with advanced civilization without experiencing civilization-level psychological trauma or social collapse. The timing of 3I Atlas arrival during humanity's transition to space-based civilization suggests coordination that accounts for technological development patterns rather than random interstellar wandering. Advanced civilizations might monitor emerging species and time contact initiatives to coincide with specific developmental milestones that indicate readiness for cosmic perspective expansion. Such sophisticated contact timing would require long-term monitoring of human civilization spanning centuries or millennia, suggesting that 3I Atlas might represent just the most recent in a series of reconnaissance missions that have observed human development throughout our technological evolution. Previous contact assessment missions might have remained undetected due to more primitive human observation capabilities during earlier historical periods. The possibility that human civilization has been under periodic observation throughout our technological development raises profound questions about the authenticity of human achievement and the independence of our social evolution. If advanced civilizations have been monitoring and possibly influencing human development for extended periods, then human technological progress might reflect guidance rather than independent discovery. Such long-term observation and possible intervention would challenge fundamental assumptions about human agency and the originality of human civilization. Our greatest technological achievements might represent anticipated developments within observation protocols designed by civilizations that have witnessed similar patterns among countless emerging species throughout galactic history. The cosmic perspective implied by sustained observation of multiple emerging civilizations suggests intelligence and institutional continuity that operates across timescales incompatible with biological consciousness as humans understand it. Any civilization capable of monitoring galactic civilization development patterns would require institutional structures and planning capabilities that span millions of years and encompass thousands of emerging species across vast cosmic distances. Such cosmic-scale intelligence and planning capabilities approach what human religious traditions might classify as divine attributes, suggesting that contact with truly advanced civilizations could challenge not just scientific understanding, but fundamental spiritual and philosophical frameworks that define human meaning-making systems. The encounter with 3I Atlas might represent humanity's first contact with intelligence that operates at scales traditionally reserved for theological rather than scientific consideration. As 3I Atlas approaches its closest point to our Sun on October 29th, the final phase of its reconnaissance mission begins. The data being collected during this critical period may determine whether humanity faces benevolent scientific observation, preliminary assessment for future contact operations, or reconnaissance preceding more significant interventions that could fundamentally alter human civilization's trajectory. The window for gathering definitive information about 3I Atlas closes rapidly as its hyperbolic trajectory carries the object away from optimal observation positions. Within months of perihelion passage, it will accelerate beyond the reach of current human detection capabilities, taking with it answers to questions that could define humanity's cosmic future. The findings locked away in classified databases may represent the most significant information in human history, analyzed by researchers who cannot share what they've discovered about our enigmatic cosmic visitor. The approaching deadline has triggered what sources describe as crisis-level decision-making within space agencies and government organizations worldwide. The classification systems that protect individual researchers from psychological trauma now prevent comprehensive analysis that could resolve fundamental questions about 3I Atlas before the opportunity disappears forever. Humanity faces the possibility that our first confirmed encounter with potential cosmic intelligence will end in permanent uncertainty, leaving us to wonder what we discovered but could never fully understand. The psychological pressure facing decision-makers responsible for managing humanity's response to 3I Atlas has reached levels that veteran government officials describe as unprecedented in their careers. The weight of potentially making first contact decisions that could affect human civilization's entire future has created stress-related health crises among senior personnel at NASA, the European Space Agency, and national security organizations worldwide. Multiple sources report that key decision-makers have experienced complete psychological breakdowns when confronted with the full implications of what 3I Atlas might represent for humanity's cosmic future. The responsibility for determining appropriate responses to potential first contact with advanced intelligence has proven too overwhelming for individuals trained in conventional diplomatic and military decision-making processes. The decision-making crisis has been compounded by the approaching deadline for 3I Atlas observations and the irreversible nature of choices being made during this critical period. Unlike typical government decisions that can be revised and adjusted over time, the responses to 3I Atlas will establish precedents for humanity's first contact with potential cosmic intelligence. The permanence of these decisions has paralyzed normal governmental decision-making processes at the highest levels. Emergency protocols developed specifically for managing first contact scenarios have reportedly been activated across multiple government agencies, creating coordination challenges between organizations that typically operate independently. The integration of space agencies, military commands, intelligence services, and diplomatic institutions into unified response structures has created bureaucratic complexity that exceeds normal governmental coordination capabilities. The international coordination required for managing humanity's collective response to 3I Atlas has revealed fundamental limitations in existing diplomatic and treaty frameworks for addressing cosmic-scale challenges. Traditional international law and diplomatic protocols provide no adequate foundation for making species-level decisions about contact with potentially advanced intelligence. New institutional structures have been quietly established to coordinate international responses to 3I Atlas, including what sources describe as a shadow cosmic affairs council that operates outside traditional diplomatic channels. This parallel decision-making structure includes representatives from major space agencies, military organizations, and intelligence services who possess security clearances for accessing complete information about 3I Atlas observations. The existence of secret international coordination mechanisms for managing cosmic contact scenarios suggests long-term planning for eventual encounters with advanced intelligence that extends back years or decades before 3I Atlas arrival. Such preparation indicates that government organizations have anticipated the possibility of cosmic contact and developed response protocols that remain hidden from public oversight and democratic accountability. The democratic implications of removing first contact decision-making from public oversight and legislative control represent a fundamental shift in governmental authority that challenges basic principles of representative democracy. Decisions that could affect humanity's entire cosmic future are being made by unelected officials operating under classification systems that prevent public debate or democratic input. Constitutional scholars have privately raised concerns about the legal authority for making species-level decisions without constitutional foundation or legislative authorization. The classification of 3I Atlas information prevents constitutional challenges to decision-making authority, creating a legal vacuum where governmental power operates without traditional checks and balances. The precedent established by classified decision-making about 3I Atlas could fundamentally alter the relationship between governmental authority and democratic oversight for all future cosmic contact scenarios. If governments can make first contact decisions without public accountability, then humanity's cosmic future will be determined by unelected officials operating according to classified protocols rather than democratic principles. The ethical implications of making irreversible first contact decisions without informed public consent challenge fundamental assumptions about governmental authority and individual rights in cosmic contexts. Citizens have no opportunity to participate in or influence decisions that could determine their species' cosmic future, raising questions about the legitimacy of such governmental power. International legal frameworks for addressing cosmic contact scenarios remain virtually non-existent, creating situations where individual governments must make species-level decisions without adequate legal foundation or international coordination mechanisms. The absence of cosmic law creates opportunities for individual nations to make unilateral decisions that could affect all humanity without appropriate legal constraints. The development of cosmic contact protocols outside traditional diplomatic and legal frameworks suggests that governments view such scenarios as fundamentally different from terrestrial international relations. The classification and secrecy surrounding these protocols prevents public understanding of the principles and procedures that will guide humanity's cosmic future. As 3I Atlas completes its reconnaissance mission and begins accelerating toward interstellar space, the decisions made during this critical period will establish precedents for humanity's approach to cosmic intelligence that will influence our species' development for generations. The classification systems that currently protect individual psychological health may permanently prevent humanity from understanding what we discovered about our first confirmed cosmic visitor and what those discoveries mean for our place in the cosmic community. The legacy of 3I Atlas extends far beyond the specific questions about this particular object to encompass fundamental changes in how humanity approaches cosmic phenomena and our understanding of our place in the universe. Regardless of whether the object proves natural or artificial, its appearance has demonstrated humanity's unpreparedness for encounters with cosmic phenomena that challenge basic assumptions about reality and our cosmic environment. The psychological casualties, institutional disruptions, and governmental secrecy triggered by 3I Atlas reveal systemic vulnerabilities in human civilization that extend far beyond space science to encompass basic social, political, and psychological foundations of modern society. These vulnerabilities suggest that genuine contact with advanced cosmic intelligence could trigger civilization-level disruptions that threaten social stability and governmental legitimacy. The transformation of space agencies from transparent scientific organizations into classified intelligence operations represents a fundamental shift in the relationship between scientific discovery and governmental control that could permanently alter how humanity approaches cosmic exploration. The precedent of classifying cosmic discoveries based on psychological impact rather than security considerations could extend to all future space exploration activities. Educational institutions have begun quietly developing curricula designed to prepare future generations for cosmic perspectives that challenge traditional human-centered worldviews. These programs represent recognition that humanity's cosmic environment may contain intelligence and technologies that require fundamental changes in how we understand reality and our place within it. The recruitment and training of personnel for future cosmic contact scenarios has become a priority for space agencies and national security organizations, creating new professional categories that combine scientific expertise with psychological resilience and security clearance requirements. Such specialized personnel development suggests expectation of regular encounters with cosmic phenomena that challenge conventional understanding. Mental health systems have begun developing therapeutic approaches specifically designed for individuals experiencing what psychologists term cosmic perspective disorders resulting from exposure to evidence that challenges fundamental assumptions about humanity's cosmic situation. These specialized treatment programs represent institutional recognition that cosmic discoveries can trigger psychological impacts requiring dedicated therapeutic intervention. The international cooperation mechanisms established for coordinating responses to 3I Atlas have created precedents for managing future cosmic contact scenarios that operate outside traditional diplomatic and legal frameworks. These parallel governmental structures represent fundamental changes in how human civilization will approach cosmic-scale challenges that transcend national boundaries and conventional international relations. The classification systems developed for managing information about 3I Atlas have established protocols for controlling public access to cosmic discoveries based on psychological impact assessments rather than traditional security considerations. These information management systems could extend to all future cosmic discoveries that challenge conventional understanding of reality and humanity's cosmic environment. Research methodologies developed for studying 3I Atlas under extreme security and psychological constraints have created new approaches to scientific investigation that balance knowledge acquisition with researcher protection and information security. These methodologies represent fundamental changes in how scientific research operates when discoveries challenge basic assumptions about reality. The technological assessment criteria developed for evaluating 3I Atlas have established frameworks for distinguishing between natural and potentially artificial cosmic phenomena that will guide future encounters with unusual objects. These assessment protocols represent humanity's first systematic attempt to develop criteria for identifying evidence of cosmic intelligence and technology. As 3I Atlas disappears beyond the reach of human observation, it leaves behind a transformed human civilization that has been forced to confront the possibility that our cosmic environment contains intelligence and technologies far beyond our understanding. The changes triggered by this encounter will continue influencing human development long after the object itself has vanished into interstellar darkness. The questions raised by 3I Atlas about humanity's cosmic situation and our preparedness for contact with advanced intelligence will continue challenging our species long after this particular visitor has departed our solar system. The precedents established during this encounter will guide humanity's approach to cosmic phenomena for generations, determining how we respond when the next enigmatic visitor appears in our cosmic neighborhood. The mystery of 3I Atlas ultimately transforms from questions about a specific interstellar object to broader inquiries about humanity's readiness for cosmic citizenship and our ability to maintain social stability when confronting evidence of our cosmic insignificance. These fundamental challenges to human understanding and social organization represent the true legacy of our encounter with this enigmatic visitor from the darkness between stars. Whether 3I Atlas represents natural phenomena or artificial technology, its impact on human civilization has already proven transformative in ways that will influence our species' development far beyond the brief period of its passage through our solar system. The cosmic perspective forced upon humanity by this encounter cannot be reversed, leaving us forever changed by our glimpse into the profound mysteries that await discovery in the darkness beyond our world. The infrastructure required for monitoring 3I Atlas has revealed capabilities that space agencies never publicly acknowledged possessing. Deep space tracking networks that officially don't exist have been activated to maintain continuous observation of the object as it approaches perihelion. These shadow tracking systems operate with precision that exceeds publicly known space surveillance capabilities by orders of magnitude. Ground stations in locations that don't appear on any official space agency documentation have been transmitting encrypted data streams related to 3I Atlas observations. Radio frequency analysis reveals communication protocols that suggest coordination between facilities across multiple continents operating under classification levels that exceed standard military security measures. The existence of such extensive covert infrastructure indicates long-term preparation for scenarios exactly like the 3I Atlas encounter. Satellite constellations that were officially decommissioned years ago have been reactivated and repositioned to provide optimal coverage of 3I Atlas trajectory. These supposedly defunct assets display operational capabilities that exceed their original design specifications, suggesting secret upgrade programs that enhance their surveillance and communication systems far beyond publicly acknowledged technological levels. The power requirements for operating this expanded surveillance network have created detectable anomalies in electrical grid consumption patterns around facilities involved in 3I Atlas monitoring. Energy usage spikes at research installations correlate directly with periods of intensive object observation, revealing the enormous computational and transmission power required for analyzing data from this cosmic visitor. Computing resources allocated to 3I Atlas analysis have reportedly exceeded the combined processing power of the world's largest supercomputer installations. The data processing requirements suggest that observations are generating information volumes that challenge current computational infrastructure limits. Such massive processing demands indicate analysis complexity that goes far beyond routine astronomical object characterization. Quantum computing systems that remain officially experimental have been deployed for 3I Atlas data analysis, suggesting computational challenges that exceed classical computer capabilities. The utilization of quantum processing resources indicates mathematical problems related to the object's behavior that require computational approaches at the absolute cutting edge of human technological capability. Artificial intelligence systems specifically designed for pattern recognition in cosmic phenomena have been developed and deployed exclusively for analyzing 3I Atlas behavioral characteristics. These AI systems operate using machine learning algorithms trained on datasets that include theoretical models of non-natural object behavior, suggesting preparation for exactly the type of anomalous phenomena that 3I Atlas exhibits. The AI analysis has reportedly identified behavioral patterns in 3I Atlas operations that display characteristics consistent with what computer scientists describe as intelligent system responses to environmental stimuli. the object appears to modify its behavior based on external conditions in ways that suggest decision-making processes rather than passive responses to physical forces. Machine learning algorithms have detected what researchers privately describe as communication attempts embedded within 3I Atlas electromagnetic emissions. These potential signals display mathematical structures that suggest information encoding rather than random electromagnetic noise generated by natural physical processes. The complexity of these embedded patterns approaches what information theorists consider minimum thresholds for intentional communication. Signal processing systems have isolated specific frequency components within 3I Atlas emissions that appear designed to penetrate Earth's atmospheric interference patterns with optimal efficiency. Such frequency optimization would require detailed knowledge of our planet's electromagnetic environment and suggests transmission systems designed specifically for communication with Earth-based receivers. The mathematical structures detected within these potential communication signals include prime number sequences, geometric progressions, and what appeared to be solutions to complex mathematical theorems that would demonstrate advanced mathematical knowledge. Such mathematical content would serve as universal communication protocols that any technologically advanced species could recognize as artificial rather than natural. Cryptographic analysis of these embedded mathematical structures reveals layered information encoding that suggests multiple levels of communication complexity. Simple mathematical relationships appear to contain more sophisticated information patterns that become apparent only through advanced decryption techniques. This layered approach would allow communication systems to verify receiver intelligence levels before transmitting more complex information. The timing of these potential communication signals correlates with 3I Atlas achieving optimal geometric positions for Earth observation, suggesting that transmission attempts are coordinated with mission planning rather than random electromagnetic phenomena. Such timing precision indicates planning capabilities that extend far beyond natural physical processes. Response protocols for potential communication attempts have reportedly been developed but remain classified at levels that prevent most researchers from understanding what procedures might be implemented if definitive communication is established. The existence of such protocols suggests long-term planning for cosmic communication scenarios that extends back years before 3I Atlas arrival. International agreements for managing potential cosmic communication have been quietly negotiated between major space agencies and government organizations, creating frameworks for coordinated responses that operate outside traditional diplomatic channels. These agreements establish authority structures and decision-making processes that bypass normal governmental oversight and democratic accountability. Communication equipment specifically designed for responding to potential signals from 3I Atlas has been constructed and positioned at undisclosed locations worldwide. This specialized equipment operates using transmission protocols that remain classified but reportedly include mathematical and scientific information designed to demonstrate human technological capabilities and peaceful intentions. The ethical implications of responding to potential communication from 3I Atlas without public knowledge or consent raise fundamental questions about governmental authority to make species-level decisions. Citizens remain unaware that their representatives may be engaging in humanity's first attempt at interstellar communication without democratic oversight or public input. Linguistic analysis teams have been assembled to develop communication protocols that could convey basic human concepts and intentions without requiring shared language or cultural references. These teams include mathematicians, physicists, philosophers, and communication theorists working to create universal communication methods that transcend species-specific conceptual frameworks. The philosophical challenges of communicating with intelligence that may operate according to completely different logical systems have created new academic disciplines focused on xenolinguistics and cosmic communication theory. Universities have quietly established research programs dedicated to developing communication frameworks for contact with non-human intelligence. Psychological preparation programs have been developed for personnel who might participate in direct communication with 3I Atlas or similar cosmic intelligence. These programs address the mental health challenges associated with contact with intelligence that operates at scales and capabilities far beyond human understanding. The security implications of cosmic communication include possibilities that advanced intelligence might be capable of transmitting information that could disrupt human technology systems or influence human psychology in ways that compromise social stability or governmental authority. Protective measures against such possibilities have been developed but remain classified at the highest security levels. Economic analysis of potential cosmic contact scenarios suggests that confirmation of advanced intelligence could trigger financial market disruptions that threaten global economic stability. Contingency plans for managing economic impacts include procedures for controlling information release and market intervention strategies designed to prevent civilization-level financial collapse. Social impact assessments for cosmic contact scenarios predict widespread psychological trauma, religious crisis, and political instability that could threaten governmental legitimacy and social cohesion. Management strategies for these impacts include media control protocols, religious leader coordination programs, and law enforcement preparations for potential civil unrest. The technological implications of confirmed contact with advanced intelligence include possibilities for knowledge transfer that could revolutionize human capabilities, while creating security risks if such knowledge falls into inappropriate hands. Protocols for managing technological information from cosmic sources remain classified but reportedly include international agreements for sharing and controlling advanced knowledge. Military implications of cosmic contact include both opportunities for technological advancement and risks of encountering intelligence with capabilities that render human military systems obsolete. Defense planning for cosmic contact scenarios reportedly includes both cooperation protocols and contingency plans for potential hostile encounters. Scientific implications of confirmed cosmic contact would revolutionize human understanding of intelligence, technology, and our place in the cosmic hierarchy. Research protocols for studying advanced cosmic intelligence have been developed but remain classified to prevent premature disclosure that could compromise ongoing analysis efforts. The long-term implications of 3I Atlas encounter extend far beyond the specific questions about this particular object to encompass fundamental changes in how humanity approaches cosmic phenomena and our understanding of cosmic civilization. These changes will influence human development for generations, regardless of whether definitive communication is established. Educational implications include the need to prepare future generations for cosmic perspectives that challenge traditional human-centered worldviews. Curriculum development programs have been initiated to gradually introduce cosmic citizenship concepts without triggering widespread psychological trauma or social disruption. Religious implications of cosmic contact include challenges to traditional theological frameworks and the need to develop spiritual interpretations of humanity's place in a cosmos containing advanced intelligence. Interfaith coordination efforts have been established to manage religious responses to cosmic contact scenarios. Cultural implications include the need to preserve human cultural identity while adapting to cosmic perspectives that may render many traditional human values and social structures obsolete. Anthropological studies of cultural adaptation to cosmic contact scenarios have been initiated to guide social transition processes. Legal implications include the need to develop frameworks for cosmic citizenship and interstellar law that transcend traditional terrestrial legal systems. International legal scholars have begun developing cosmic jurisprudence concepts that could govern human interaction with advanced cosmic intelligence. As 3I Atlas approaches the final phase of its solar encounter, the accumulated evidence suggests that humanity has encountered phenomena that transcend our current understanding of natural cosmic processes. Whether the object represents advanced technology or exotic natural phenomena, its impact on human civilization has already proven transformative in ways that will influence our species' development far into the future. The precedents established during the 3I Atlas encounter will guide humanity's approach to cosmic phenomena for generations, determining how we respond when future enigmatic visitors appear in our cosmic neighborhood. The institutional changes, technological developments, and psychological adaptations triggered by this encounter represent permanent alterations to human civilization that cannot be reversed. The questions raised about humanity's readiness for cosmic citizenship and our ability to maintain social stability when confronting evidence of advanced intelligence will continue challenging our species long after 3I Atlas has departed our solar system. These fundamental challenges represent the true legacy of our encounter with this mysterious visitor from interstellar space. The mystery of 3I Atlas ultimately transforms from specific questions about an individual cosmic object to broader inquiries about humanity's place in a universe that may contain intelligence and technologies far beyond our current comprehension. The cosmic perspective forced upon our civilization by this encounter has already begun reshaping human understanding in ways that will influence our development across multiple generations. The technological capabilities demonstrated by 3I Atlas, whether natural or artificial, have revealed the vast scales of engineering and intelligence that may exist beyond human experience. This revelation challenges every assumption about human significance and technological achievement while simultaneously inspiring new possibilities for human development and cosmic exploration. The psychological impact of confronting cosmic phenomena that challenge basic assumptions about reality has demonstrated humanity's limited preparedness for genuine cosmic contact. The mental health casualties and institutional disruptions triggered by 3I Atlas reveal vulnerabilities that extend throughout human civilization and will require generations to address adequately. The governmental and institutional responses to 3I Atlas have established precedents for managing cosmic contact scenarios that operate outside traditional democratic oversight and legal frameworks. These precedents will influence how humanity approaches future cosmic encounters, regardless of whether they prove natural or artificial in origin. The scientific methodologies developed for studying 3I Atlas under extreme security constraints have created new approaches to research that balance knowledge acquisition with information security and psychological protection. These methodologies represent fundamental changes in how scientific investigation operates when discoveries challenge basic assumptions about reality. The international cooperation mechanisms established for coordinating responses to 3I Atlas have demonstrated both the possibilities and limitations of human coordination when facing cosmic-scale challenges. The successes and failures of this coordination will influence how humanity manages future encounters with cosmic phenomena that transcend national boundaries. The classification systems developed for managing information about 3I Atlas have established protocols for controlling public access to discoveries that challenge conventional understanding. These information management approaches will likely extend to future cosmic discoveries that possess similar potential for social disruption. The communication protocols developed for potential interaction with 3I Atlas represent humanity's first systematic attempt to establish contact with non-human intelligence. The success or failure of these protocols will guide future communication attempts with cosmic intelligence regardless of their origin or intentions. The technological assessment frameworks developed for evaluating 3I Atlas have established criteria for distinguishing between natural and potentially artificial cosmic phenomena. These assessment protocols will guide future encounters with unusual objects and help humanity develop more sophisticated approaches to cosmic intelligence detection. As 3I Atlas completes its passage through our solar system and accelerates toward interstellar space, it carries with it answers to questions that could define humanity's cosmic future. The information gathered during its brief visit may represent the most significant intelligence about cosmic civilization that our species will possess for generations. The transformation of human civilization triggered by the 3I Atlas encounter represents just the beginning of adaptations that will be necessary as humanity develops cosmic perspectives and potentially encounters additional evidence of advanced intelligence. The changes initiated during this encounter will continue evolving long after the object itself has vanished into the darkness between stars. The legacy of 3I Atlas extends beyond specific questions about its nature to encompass fundamental alterations in human consciousness and institutional structures that will influence our species' development throughout our transition to cosmic citizenship. Whether we encountered natural phenomena or artificial intelligence, the impact on human civilization has proven permanently transformative. The cosmic perspective imposed upon humanity by our encounter with 3I Atlas cannot be forgotten or reversed, leaving our species forever changed by this glimpse into the profound mysteries that exist in the darkness beyond our world. The questions raised during this encounter will continue challenging human understanding and social organization for generations as we struggle to comprehend our place in a cosmos that may contain intelligence and technologies beyond our wildest imagination. The approaching departure of 3I Atlas from our solar system marks not the end of this cosmic mystery, but the beginning of humanity's permanent awareness that our cosmic neighborhood may contain phenomena that transcend our current understanding of natural processes and technological possibilities. This awareness will influence every aspect of human development as we prepare for future encounters with the unknown forces that govern cosmic civilization. In the final analysis, 3I Atlas has revealed more about human limitations and vulnerabilities than about cosmic intelligence or advanced technology. Our response to this enigmatic visitor has demonstrated both the remarkable adaptability and the profound fragility of human civilization when confronted with phenomena that challenge our most fundamental assumptions about reality and our place in the cosmic order. The true significance of the 3I Atlas encounter may ultimately lie not in what we discovered about the object itself, but in what we learned about humanity's readiness for cosmic citizenship and our capacity to maintain civilization when confronting evidence that we are not alone in a universe filled with intelligence and technologies that dwarf our greatest achievements. As this mysterious visitor accelerates beyond human detection capabilities, it leaves behind a transformed species that must now navigate a cosmic future with the knowledge that our solar system has been visited by phenomena that operate according to principles we are only beginning to comprehend of human cosmic end. The age innocence has ended, replaced by an awareness that will define our species' development for millennia to come. The questions that will haunt humanity long after 3I Atlas disappears into interstellar darkness concern not just the nature of this particular visitor, but the broader implications of living in a cosmos where such phenomena exist. Whether natural or artificial, the capabilities demonstrated by 3I Atlas suggest that human civilization occupies a universe far stranger and more complex than we ever imagined, populated by forces and intelligences that may forever remain beyond our understanding. The cosmic humility forced upon humanity by our encounter with 3I Atlas represents perhaps the most valuable legacy of this mysterious visitor. In confronting phenomena that transcend our technological capabilities and challenge our understanding of natural processes, we have been reminded of our place as a young species taking its first tentative steps into a community cosmic that may extend far beyond our current ability to comprehend or participate. The psychological aftermath has created a generation of researchers who can never return to conventional astronomy. Dr. Rebecca Martinez, who spent 20 years studying conventional comets before joining the 3I Atlas project, describes her transformation in terms that sound more like religious conversion than scientific evolution. She speaks of a before and after in her consciousness, a fundamental shift in how she perceives cosmic phenomena that makes traditional astronomical work feel like examining shadows on cave walls after seeing sunlight. Martinez represents dozens of researchers who have essentially become cosmic refugees within their own scientific disciplines. They possess knowledge that makes conventional astronomical research seem trivial, yet they cannot share this knowledge or return to their previous understanding of cosmic reality. They exist in a liminal space between human ignorance and cosmic awareness that proves psychologically unbearable for many. The institutional memory of space agencies has been permanently altered by the 3I Atlas encounter. Procedures, protocols, and decision-making frameworks developed during this crisis have become embedded in operational structures that will influence how humanity approaches cosmic phenomena for decades. Emergency response systems designed for cosmic contact scenarios have been integrated into standard operations despite officially remaining classified. Training programs for new space agency personnel now include psychological preparation components that would have been considered science fiction just months ago. Recruits undergo evaluation for cosmic perspective resilience and receive instruction in managing information that challenges basic assumptions about reality. These training modifications represent permanent changes to how humanity prepares individuals for cosmic exploration careers. As 3I Atlas accelerates beyond the reach of human observation, disappearing into the cosmic void from which it came, it leaves behind more questions than answers. What we've witnessed over these crucial months represents either the greatest astronomical discovery in human history or the most sophisticated natural phenomenon ever encountered. The truth may be locked away in classified databases, analyzed by researchers who cannot speak about what they've discovered. The transformation of human civilization triggered by this encounter cannot be undone. Space agencies have evolved from transparent scientific organizations into classified intelligence operations. Researchers have experienced psychological trauma that reveals our fundamental unpreparedness for cosmic contact. Government decision-making has shifted to shadow councils operating outside democratic oversight. These changes will influence how humanity approaches cosmic phenomena for generations. Whether 3I Atlas represents advanced reconnaissance technology or exotic natural processes, its impact has already proven transformative. The cosmic perspective forced upon our species cannot be reversed. We now exist with the permanent awareness that our cosmic neighborhood may contain phenomena that operate according to principles beyond our current understanding. The questions raised during this encounter will continue challenging human civilization long after this mysterious visitor has vanished into interstellar darkness. Are we alone? Are we being watched? Can we maintain social stability when confronting evidence of cosmic intelligence that dwarfs human achievement? The answers may determine whether humanity successfully transitions to cosmic citizenship or retreats into willful ignorance of the profound mysteries that surround us in the darkness beyond our world. The age of cosmic innocence has ended. What comes next will define our species for millennia to come.